Okay, welcome to session 7 for our sessions about design patterns, classical level design with evolution to system design. A little bit about myself. I worked in industry for more than 10 years. I am sharing everything based on my career experience. And my career experience about working with high-load system in banking systems, in Yandex search systems, and build it to support millions of customers. So I touched a lot of patterns in my own site and in my own experience, and I hope you can get the most from the sessions. Now, before we proceed, anyone is brave enough to share if you remember anything about any of this pattern from last session? Would you be happy to say a few words? Maybe some of them you really liked. Yeah. You can raise your hand or put it in panel as well. Maybe you liked something from patterns we covered last time, or something like especially memorizable, or something you found that you're using under some framework. So I'm going to start. So for chain of responsibility, I was questioning if it's decorator or chain of responsibility that we're using today when we build API calls, which is mean we build HTTP calls for requests and response. And we basically need to do a lot of things like authentication, authorization. We make cache responses, so we get it directly from cache. We may want to do something like debugging or logging, tracing. So we can do it through decorator pattern. We discussed it in second session of this course. But there is one more pattern, which is chain of responsibility, and that's applicable for the same, absolutely the same task, like basically to build chain of filters to make sure that when you accept HTTP requests or gRPC, REST HTTP request or gRPC HTTP request, they could be all HTTP requests. And when you accept it and when you build response, you basically go through many layers in application. So I was questioning if I'm looking in very popular framework for Java ecosystem, Java or Kotlin, that's called Spring Boot. Basically, you can spin up a server that's going to accept requests and help you to build responses quite quickly without basically coding all the stuff like how to accept HTTP request, how to open socket, how exactly we can parse header and body and exactly entities of request and response in our application. A lot of these things today covered with framework in Java, Kotlin, Java ecosystem. We can use Spring Boot for this. And I was questioning what pattern it uses under the hood. Is it decorator or is it chain of responsibility? The answer is both. Both patterns are used. And the chain of responsibility, indeed, you can use it to build filters. And if you need something like caching, you can add one more filter, which will be part of this chain. And this filter will contain, map for cache and request response, for example. And this map will help you to reply quickly if it's very popular request, or it's like user who's coming every day with the same question, with the same request, basically. For example, the request just to give me homepage. That's the most popular users that will ask you every day for the same question if they love your service, and you can cache this one. So basically, we discussed in session second that you can build it as decorator, like decorate your acceptance of requests and responses. But if you use Spring framework, you create a filter. It will call like something like web filter that Spring will pick up for you. It will inject it in all filters that already automatically do some work for you, like authentication. And then you will use it in this filter. And that will mean you are using kind of indirectly chain of responsibility for this task. So yeah, and if you ever build server with request response, maybe you can think about the frameworks that you are using and how like chain of responsibility can help you to build all this work with accepting requests and at the same time giving back response. And if we're talking about logging and monitoring, we will use still decorator because we basically will like decorate our requests and response in the way that we want. So any questions so far about requests, response? Anything about these patterns? Any questions according to frameworks that you've tried on your own to build maybe something like this? Yeah, if you would have it, do not hesitate to go and ask in channel. So we will look together as well. Now, we were looking at mediator pattern, and our decision was that it's mostly used today in concept of system design patterns, and the most similar concept to this, something like orchestration or Google workflows. So that's when you basically, you don't want every application knows about another application. On low level, that means like you build series of actors, classes, and you don't want everyone knows about each other. Instead of it, you move in this knowledge to centralized place, which will be mediator. And we agreed that on system design level, it will be orchestration pattern. So basically, when you want to orchestrate the work of your microservices, or if you build data pipeline, you may think about aggregating few different data sources on centralized place again, and like making decision what to do with it. We discussed bridge, and we discussed that this pattern more about decoupling things when you see a lot of changes that come into the same subject. So in the very, very simplified concept, we have a finger, some shape that could be ball or it could be cube, and we have two colors, which is blue and red, and we say from every time we implement the service that's responsible as a blue cube and do everything as a blue cube. Another one will be red cube, another one will be red ball, another one will be blue ball. But bridge is about that we see that actually we may add more and more colors, while we also could add more and more shapes. So when we see that something like this happening with our services and data, we want to decouple that. And it looks like very basic decoupling of microservices if we move into system design level. And last one that we've covered, Memento. And we discussed that today in system design. Memento as a pattern could be very good memento note, very good reminders that you would like to create a snapshot whenever your data hits in some service. So if you start application, if you start to build microservices system, ecosystem, you would likely to have snapshots of a message coming to every single microservice, because in this case, it will be easier to debug and to understand what happened and recover the state. It's not necessary, could be some data in database. You may just publish event about what has happened in microservice when data came in. And this chain of events will always help. It will be like your snapshot, and it will help you to recover what state was there when the request hit first ever microservice, second microservice, and so on. So Memento exactly about this. If you think about example in book, because example in book say we build a game that has 7 levels, but if user ever failed on some level, they have to start from scratch. And that's the same when we build distributed system. If our request failed past service A, service B, service C, and then they failed, we would like to know what's happened at service A, service B, service C. And when we ever retry service C, we may actually recover from the latest state from service B and continue to go like this. So it can help us a lot. And it can help us to save a lot of cost to debugging the system, to understand what's happening, and basically to not retry requests from the beginning. So user would have actually good response what's happened. And that's another system design pattern that can help with it. But we will cover it in another course on system design. Okay, now, if you have any questions about any patterns, and if you liked some of them really much, just let us know in the chat or in channel. So today we're going to talk about very rare patterns. It's harder to find examples about them because even in the books I did research which patterns they've seen the most before they wrote the book. And they put them in kind of additional patterns. And if you go in this book, you will find that very, very little information about these patterns. However, in this course, you can see more things. Let's start with visitors. So this pattern, the example from books that you build a menu, and this menu have menu items, and every item have ingredient. And the challenge is how I would go through everything in the menu. And they use visitor pattern because they provide a clear structure, which basically tree-like structure. So we touch popular data structures, tree structure, when we build this pattern. And they say like every item will have all of these methods. And because when we go and visit them like a tree structure, we can guarantee that we visited all elements. Yeah, so that's how it looks like. Basically, the client asks the visitor, it's not like client should go through the whole menu, but client asks visitor to basically check everything, like what is a menu, what is a menu item, and what is an ingredient. As a kind of showcase in the book that we would like to figure out if it's all available. And we also want to calculate a lot of things like calories, if like what proteins of basic health rating when we calculate all of these. And we basically want to do it for each menu item, but the thing that in each menu item you have ingredients and you calculate it based on these ingredients. And for this, there is a pattern to help you to do it in a better way. Let's have a look what Refactoring Guru is telling about visitor. So they come with the concept of menu. And they say that, the class diagram will be like, you have basically elements, you have implementation of elements, and you have visitor who has this function implemented, who have to implement this, basically visit every element. So this is this pattern. Example, when you have to render different things in basically when you need to support the hierarchy of geometric shapes. Yes, so that's again like we say that dot, circle, rectangle, etc., they all shapes. And when you want to write an application, you actually can try this one because it's really, I think the one you can really try on your own because it gives you even the application render it, so you can play with it. If you go to Java example, I played with it in Java example because I wanted to see how useful it is. So basically, implementation here, you can even try it again on your own, how it can help you. And yeah, the idea is that, okay, it's implementation, and the idea is that this is how you can go through all these figures to do calculations, for example. By the way, whenever language you use, a lot of implementation you can find on this website. Okay, let's look next. So overall visitor, when you need to perform an operation on complex elements. And as an example from Python language, that's how you can implement it in Python. When you want to go to exhibition, but there is painting exhibition, there is sculpture exhibition, and you also have get artists and get materials, and you build tour guide to help you to visit everything, which is one visit all paintings, another one visit all sculptures. So you can build an application and give to someone as a tour guide, something like this. Now, I will be honest, I've never seen the task like this, but I was looking where it's implemented in real life, and the first ever example that's coming there is compilers. So basically, if you think how your programs is going to be compiled, for compiler, your program is a set of elements, a lot of elements. So how it works, all elements that are written, basically they create abstract syntax trees. That's how it's called. And in these abstract syntax trees, every node, it could be, so every node is a word or even more complex element, which is mean it could be variable, it could be function, it could be operator. So basically, to figure out what the program should do, everything visited by visitor, and then it's create bytecode, and then it's going to assembler code, because, and then it will go to clear commands, to operation system, how to execute your program. That's how it works under the hood. So everything analyzed by as a compiler, as an interpreter, and we will actually look at this soon, and then how it's becoming performed program. Yeah, so that's it's example from real life. It's kind of if we use compiled languages, we definitely use this pattern under the hood every day. Just we are not realizing that we're using it. Flight weight pattern. That's also very interesting pattern, very interesting one. Okay, so we're going to look at the video to make this more interactive. And if you remember to translate the sound, I should go to another mode, and I hope it won't be too loud, but just be ready. If it will be too loud, be ready just to lower sound a little bit. So we're going to look at games, how they looked like when they were developed in 1978, first ever games. Let's look at them. So we see here a lot of very small and trivial graphics, right? You may be at interesting done this illustration, for example. Yeah, okay. This was just a small pause. Let me return back to presentation. You will understand when I'm showing it just in 1 second. Okay. So continue to slideshow. The example in the book is about the game that's developed in this era, because we developed a very trivial game where we have just objects on the screen, 2D objects, of course, 2D objects. So we basically build house and we build trees around house. So imagine you develop a game where you can, I don't know, build a farm. And that's very simple, like you have colors, you have tree colored in green, you have house, etc. So what is the problem? The problem is that your user may generate a lot of trees around, a lot. And what we need to know about trees? We need to know XY location, and they can be drawn again dynamically. And the problem that if we every time give all information about every single tree, it will quickly crash the memory of the game, because we think it's like very small memory as well. Yeah. All our game will wait much more than we expect. Actually, today we can rely on kind of large storage on our own devices. However, we still will pollute the game, the memory of the game, if we just give all characteristic of every tree that we create. And lightweight pattern about, okay, actually we don't need all information. We don't need to repeat color every time. We don't need to create the object that's responsible for color every time when we create a new tree. We basically should create a lightweight representation. I would basically call it today not flyweight. I would call it lightweight, something like this, because I would think about data to be heavy and light. But yeah, like it's so light that it's flying. That's why it's called flyweight. So the idea is that we're going to create flyweight objects, which basically contain only XY, and everything else will be rendered from single state-free object that store color. In this case, we do not create a lot of things that may replicate each other. And as I said, like green color, we don't need to create object of green color every time in this case. To render green color, we render it from static tree object, which like we created once. This is the tree. But we basically, all a new tree will be displayed, we'll store X, Y, and H, and the color, and I don't know how many circles you would do, depends on H. That will go from static object, so you don't need to replicate heavy objects. That's the idea of the pattern. Let's look at what example could give us growth pattern. So that's basically how it looks like. This is old objects before we applied lightweight, and another one trying to go. While this is one as our tree that has all heavy information about how tree should look like. And that's our lightweight objects, small trees. Sorry, I do not share. Just a moment. Share this one instead. Yeah. So yeah, this is good. This is good graphics that pictures idea. Now, if you look here, this is our objects before our implementation. They are quite heavy. That's why this is shown like this. Like these objects are heavy because what we've done, we replicated the whole object with all fields, everything that's needed. But we could do it better and save a lot of memory because we could just create static object that's responsible for calculation, responsible to storing colors, responsible for maybe derive color, like depends on the age of the tree. Like it could be, I don't know, light green for very young trees, and it could be very dark green for very old trees, for example. But basically, that's all will be static. You should be careful, do not replicate objects that will store this information, or the object that will store all these calculations. And you can think about data-oriented programming that we talked in a session, definitely about creation of patterns. And as the first session, I think I also covered data-oriented programming. In data-oriented model, we said that model should be responsible for calculation as well, because only it's like model layer. Model layer is responsible for this. But we say if you want to create new objects in memory or even store them on the hard disk, it doesn't matter. You still can benefit a lot from this pattern by saying, okay, this is my light representation of the object that I want. How you can use it as well today. For example, you don't have to develop a game, but you still could benefit from this pattern. So you could think about this static object as representations that you want to wrap in the most compactable format. The most compactable regarding serialization. So formats, serialization formats, I know. XML, the most heavy one. JSON, the middle one. Database records, that will be its own format for serialization. It's hard for me to say which one, but basically you send data over JDBC connection to database. In Java, you send it through JDBC connection, and you may use other protocol with other ecosystem. And that will be serialization exactly for this database for record. Then proto-serialization. Proto-serialization, one of the lightest. It was developed by Google. It was developed more than 10 years ago, I think, already, but it became very popular because they found the way to make it 10x smaller than classic JSON. And that's how gRPC framework then appeared to basically move around proto messages instead of JSON messages. And the last one I know, Avro serialization, that came at the same time as ecosystem with Kafka messaging coming, and they even have a lot of support for Avro serialization. So basically, how you can use today this lightweight pattern, it will be a little bit different because we are not going to talk about static object here, but we are going to talk that you still may have a light representation of your object, and you still have heavy representation of your object. But heavy one could be wrapped in the most compact serialization level, and you can store it like separately from heavy one, from light one. And in this case, light representation will be kind of your hot data that you want to search all the time. You want to build indexes on this data so they are searchable, those fields, those records. So when we render a tree, we said we need X, Y as variables that we're going to use constantly. So they're going to be part of our light object. And now you say that you basically want to, I don't know, make them searchable. So you use it as your light representation as a hot data, while everything else you can wrap and put as a cold data because you don't need to search on this data. And that's how you can save on performance. So that's how you can do performance tricks with your application. Even like it's not building games, it's not like having things, but it's just having some data to work with. If I talk about light views and heavy objects, heavy views, you can also think about building in data engineering, there is a way to build views. So basically you build light views for analysts to see data that exactly they need. Again, like, another thing to basically log only fields that you need. So that's also will be light representation, light records. So you need, I don't know, anything that you need to be searchable to log. So you don't want to pollute your logs with too many data. And it also will be hard to read from your logs if you put things that you may don't need. So you log only light view, especially if you have very big chunk of data. You may log only ID for this data, which will be your flight record. And as soon as you have traceability and you know what ID you would like to trace, you have this ID and then you go and see what exactly data you wanted to, you extract this data, deserialized. It could be again in the most compactable way, but then you deserialize it and you look at this data and see what exactly happened. So that's how you also can save the cost on logs, for example, if you really need to save the cost and if you have very, very heavy objects that generate tons of logs for you. That's kind of performance tricks that you could use to optimize performance. So you see here, then they applied this pattern. They said there is a game, and this game has particles. And again, these particles could have a lot of things under the hood. And basically, we always created new particles as a whole object with all coordinates, x, y, the vectors, the speed of the particles, color, everything. But when they applied lightweight pattern, they said that this particle, we should create two things from it. The one will be a moving particle, and that's going to be our more like unique state. We are not going to, we're going to basically able to change moving particle, and then we can also have immutable static state particle that will have color, that have sprite, and we also have different methods like move. And so that's how they optimized. Basically, it may feel counterintuitive because they created one more abstraction. So basically, they said we're going to store a particle, but we're going to create a lot of moving particles, but not the whole particle. And they claim that even kind of moving few fields to static world, that gave them huge improvements in the RAM cost. So they say before we have 21 giga, and then we have 32 mega, which kind of big improvement. So that's the concept of this pattern. This pattern to improve performance. Okay, let's go next. Let's go again. So basically, you can use it when you need to support a huge number of objects, and you want to optimize by thinking like, okay, what I can compact or what I can actually do as static things instead of creating a new object or basically creating new data object. So when we were searching for some things that exist today, because I came from Java world, the first thing that's coming to me is that there is small performance optimization in Java when you create strings. They basically create in heap memory, and you can compare them by just equal sign. So that's kind of a trick Java used to optimize performance. So they do not basically create string object every time for you if it's the same object. They just reuse existing object, which is kind of smart. I think it works when you have a lot of repeatable data instead of creating just new strings. It just will reuse the same string from memory. That's kind of trick that developer solves the language down for us. Yeah. So you can go around this one if you create new string. I don't know, anyone actually working with Java from everyone who joined us today? Could you raise your hand? Okay, I guess everyone who didn't. Okay, someone raise hand. Melanie, yeah? No, someone. Who is it? Okay. Okay. Now, another example, which is actually a good one, database connections. Basically, these are some smart things that developers of databases did for us. Again, we are using it. We may still not know about it. But when we connect to database, we do not create a new session every time. Instead of it, databases, they basically give us session from existing pool. That's if you would ever work with pool of connections, if you need to manage these things, if you create a new pool of connection for your databases, that will be good to understand. I think Irina shared this me that she works in Java. Okay, text rendering and graphic applications. Yes, so if I go next, I think that for software like this, which is I've tried by myself, I just wanted to figure out what is there on the market that I could experiment with for free without being designer, but like, let's see if I can help myself to change the things, moving the things around, like what is there on the market. So this is software that I've tried by myself and software. So I think this one is using this lightweight pattern to basically not create the whole thing. So you see, like, there is two similar tables. That's how you can think about lightweight pattern. Instead of creating the whole table with color, with like parameters, it's made from wood, etc. It just create a light object and just change coordinates like x, y, z. In this case, it's 3D. It's a kind of modern software, and basically, I think everything like color and like kind of root structure, etc. It's static data, so it doesn't create this characteristic every time when you click and create new table, like new bed table. Yeah. So that's the analogy that's coming to my mind as well. Yeah. Okay. Now the next one, interpreter. I hope I pronounce it okay. And this is more like designing your own language pattern. So the example from the books, we had in first ever session in this book, we had duck simulator, which was a game to create ducks, and we were discussing strategy pattern in first ever session, like how we can leverage from different interfaces to give them behavior by implementing it. First of all, interface, which is behavior, and then implementation of the interface, and that's how we can make them much more flexible. So we can say that Rab duck, she's not going to fly because she has no fly behavior implementation. So now we say that we would like to make it a great educational tool for children to learn programming. And we can give it in the way where they can build language. And in this case, we're going to use interpretation of these languages. And with this amazing class diagram, how it will be done in object-oriented world. So basically, there is expression, then we create repetition, sequence, variables that's responsible for commands. So if you would ever want to implement your language, you now know that there is a pattern that can help with it. You shouldn't reinvent it. Okay, I couldn't. I think that's I edit for fun. And let me present the whole window so you could see this example as well. So let's say that is a guru pattern example, and there is even no example for interpreter. And let's go to catalog and just check what is happening, why we couldn't find it. Okay, let me try again, and let me go to design patterns. Yes, catalog, creational. So which one is it? Behavioral. I think it's behavioral and structural. So it's behavioral one, but there is no this pattern. It's true. There is no pattern like this. And I'm sharing it because it's unfortunately so unpopular, so they even didn't bother to put example. I mean, unpopular by the fact that it seems like indeed you would never able to. Well, again, it depends what you do, and maybe you want to play with writing your own languages, and maybe you want to understand how it actually works when you put command in terminal and you say it will be Python, and then it's create the result straightforward because it's past compiler. It doesn't need to compile this one because it uses Python interpretation. So that's the idea how you could program by just saying like, okay, Python, and then you code basically. And Java also did it at some time. You can use Java interpreter as well, like that it's from Java 9. I remember that it came from Java 9. You can basically start to program in terminal. Why? Maybe just to figure out the syntax of Java, because you maybe just started to do this. Okay, so there is a usage of this pattern to basically build calculator to calculate. So That's more like, again, if you experiment with language, if you learn this language, why wouldn't you build calculator? So that's at least when I was learning languages, it was a popular task to basically learn the language itself. And with this new way to look at this task, to basically create it through interpreter pattern. Yeah, so basically you create it in a bit different way, and that's different, more complex class diagram as well. Now, so to make it more interactive, I'm going again to switch, just because it's evening, so I think it will be good for you as an analogy of this pattern. So stop sharing this one and this one.
Toxin, stop. Gnome in grave danger, stop. Please help. Stop.
So basically, they use a language. You maybe heard about it. I'm sure that it was very popular when in telecommunication system before we had modern telecom system. So this one was oh, okay, why, yeah, this one Morse code. And anyone recognized cartoons that I showed? Just for fun. Yeah, I see that Melanie recognized it. Yes, that's called Bolton. I can type in chat. And if you would want an evening for some very good cartoon, this one I was watched it as a kid, but I was watched it so many times because it's very good one. It's really, really good one. Yeah, it's really nice one. Okay, so in compiler and interpreters, we use this pattern as well. There in this example, you own D cell, and I would say that it still may be popular if you ever met very complex structures, and you feel like you can try to use your own D cell. And I've seen it in companies when they go with a huge and large system, and then they realize that actually we want to build D cell for people to use it. So we want to give people opportunity to basically build something. We will consume it, and then we will do the work instead of us programming every time what they want. Example from my own career experience. I regret I didn't know the interpreter pattern at this point of time. Maybe it could save me a lot when I was doing this, because I was doing it in a very simple way. Just let's parse word and let's parse the input, and that's it. I didn't use complex pattern for this one. I was using it in straightforward way, but again, I can't return now to go back and see if it's like how exactly it could simplify the things. And I understand that the most it could simplify the support of this interpreter. Now, so what is happening here? You have a marketing manager, and marketing manager coming to you and say, hey, I want to generate some data that I want to feed to Google ads or to Facebook ads or to something else ads. And they come in kind of almost every week because they're running a lot of experiments, and they want to give this to advertising platforms, and they want to say like, hey, let's add colors today. Hey, let's add, I don't know, so what is it? Let's add this URLs to pages and to see like if it will work. Let's add these filters, let's add this. And they actually come in repeat. So you never end up of having tasks. The problem is that at some point, you're figuring out that you're doing basically the same tasks, and it's not what you want to do as a developer. You want to do different tasks. You want to progress with learning system design tricks, etc. So this was example where personally I could do next. I could tell them, you know what, you every week want something new. Let me give you DSL. Here is a way to submit this request. Here is how we defined these amazing shiny filters. So basically, you telling me like what is the title of the field. You want just make sure that it's different title every time. Otherwise, we may, I don't know, override the same titles. Put their description that you want to add platforms, etc., and put the fields. And this is the list of fields that we can do. So developing this tool takes so much more time rather than just giving them the same fields that they want. But when you do something like this, you're finally free. You only support this one, but then you can move to some more interesting tasks. And that's happening when you have product owners, or in this case, it was marketing managers who were my client. And they constantly want for you to do things, but you find out that you basically just change a little bit. And yeah, that's tool helped a lot to reduce a lot from all their requests, and also unblock them to generate whenever they want, to do experiments every day instead of waiting for weeks if some another important project is coming and the developer needs to focus on this project. So even they've put this in kind of additional patterns. That's something that I've seen in my experience, and I've seen it in my colleagues' experience, who again like moved to DSL to give to analysts to build data sources, even from developer to developer. So basically, when you see that you have very dynamic things in softwares that you build, kind of clients that want all the time, every day, something could be different. This is the way where you can leverage and write DSL by yourself, which is mean you also write language for them. And again, it may be something very simple, like for the person, like the same as for kid to build language to teach dog to talk. Yeah, but what is important that sometimes it's indeed the case. And if you think about moving DevOps to ideas of scripting everything to Terraforms or Helm charts and all with YAML DSLs, it's also the cool way where they introduce a language how to spin up a lot of microservices at the same time. So that's one of the example of. So YAMLs itself is an example of the way to leverage just key value concept of building description, and then give it to software, and then create a lot of things from this and making it replaceable, easier, instead of programming every time the way how you want to do this. Okay, so we've done these patterns today, and this is basically the pre-last session on this course. Now, there is a chapter on how to combine patterns. You can read the chapter, or you can try experiment by yourself. Like, okay, these are patterns I learned, how I combine them. And that's next one will be the last one. And we're going to also issue certificates and celebrate everyone who were for all these weeks with me at this course. Okay, I'm going to stop sharing here. Thank you so much. And